So now we're going to take what we know about solving linear and quadratic equations and solve some other types of equations. So the kinds of equations we'll be solving in this section include equations solvable by factoring, equations quadratic in form, radical equations, that is, equations involving square roots, and absolute value equations. So first of all, solving by factoring. We've already seen that this is one way of solving some quadratic equations, but there are also other equations that aren't quadratic equations, but that we can still solve by factoring. Same strategy, get a 0 on one side of the equation, factor the other side, set each factor equal to 0, and solve for x. For example, 4x cubed minus 12x squared minus 40x equals 0. Not a quadratic equation because it involves x to the third power, but it is one that we can solve by factoring. So we do have a 0 on one side. And then on the other side, I notice there is a common factor. Well, the greatest common factor that we can pull out is 4x. So when you pull that out, it's 4x times x squared minus 3x minus 10. And then that x squared minus 3x minus 10 can be factored into, do you see what the factors are? X minus 5 times x plus 2. So now we have 4x times x minus 5 times x plus 2 equals 0. Then give each of those factors its own equation where it gets to be equal to 0 all by itself. 4x equals 0, or x minus 5 equals 0, or x plus 2 equals 0, and then finish solving each of those. So we get x equals 0, or x equals 5, or x equals negative 2. So those three numbers are the three solutions to this equation. And it's not just a coincidence that this equation with an x to the 3 power in it does have three different solutions. We'll talk more about that in chapter 3, how a polynomial equation like this can have as many solutions as the degree of the polynomial, the highest power that the variable is raised to. Now let's talk about equations that are in the form of a quadratic equation. Instead of just the variable being squared, you maybe have something else, something a little more complicated. But you have a term involving something squared, and then another term involving just that something, and maybe a constant term. So it's like a quadratic equation, only where a quadratic equation just has an x or a y or something like that. This might have something more complicated. Examples of the kind of thing I'm talking about would include 4 times x minus 3 squared plus 7 times x minus 3 minus 36 equals 0. This is like a quadratic equation where the variable, the thing that's being squared and then it appears just to the first power, is x minus 3. Another example, x to the 6th plus x cubed minus 6 equals 0. Since if you took x to the third power and squared that, you would get x to the 6th. This is like a quadratic equation where the variable in the equation is x cubed. It's got an x cubed squared term and an x cubed term and a constant term. So if you thought of x cubed as a variable, it would be a quadratic equation in terms of that variable. And 6x to the 2/3 minus 7x to the 1/3 minus 20 equals 0 would be like a quadratic equation if you thought of x to the 1/3 power as the variable in the equation. Because if you square that, you get x to the 2/3 power. So now let's see how to solve things like this. here's our strategy. I'm going to make a substitution that makes it actually become a quadratic equation. I'm going to use a different letter, u, to stand for the something that's being squared and then just appears by itself. So once I make that substitution, it's going to be a quadratic equation. We can go ahead and solve it to find out what u has to equal, and then we can unsubstitute. We can replace u back with the thing that it's standing for and finish solving for the original variable, x or whatever it was. For example, here we have an equation where it's like a quadratic equation, except the thing that's being squared and then appears just to the first power is x over x plus 6. So I'm going to let u stand for x over x plus 6. I'm going to rewrite this equation, but where it used to have x over x plus 6, I'm just going to put u in place to stand for that. U squared plus 3u plus 2 equals 0. You can use any letter, but it's traditional to use the letter u when you're making a substitution like this. Maybe because the letter u doesn't get used for very many other things. So when a mathematician makes a substitution, he likes to put in u to remind him, hey, that's standing for something else. And when we finish solving, we better unsubstitute and find out what that something else really is. So you can think of that letter u as standing for you better remember to unsubstitute. But we're not there yet. Right now, we can forget that u stands for anything temporarily and just focus on dealing with this equation right here. U squared plus 3u plus 2 equals 0. So if I just walked up to you and handed you that equation and said, here, solve this quadratic equation, u squared plus 3u plus 2 equals 0. Here's how you can do it. You can factor into u plus 2 times u plus 1, u squared plus 1u plus 2u, there's 3u plus 2. Then set each factor equal to 0. U plus 2 equals 0 or u plus 1 equals 0. Then finish solving each of those to get what u is equal to. U equals negative 2 or u equals negative 1. It looks like we're done, but here's where we have to unsubstitute. Remember, this u is really x over x plus 6 in disguise. So here's where we rip off the disguise and see who we're really dealing with. It's really x over x plus 6 that's equal to negative 2, or x over x plus 6 that's equal to negative 1. So we still have to finish solving each of these equations to get x equals some number. Okay, so how do we do that? Well, when there are fractions involved, we can kill the fractions by multiplying both sides of the equation by the denominator. So if I multiply both sides of this equation by that x plus 6, over here x plus 6 times x over x plus 6 gives me just x. Over here, x plus 6 times negative 2, when I multiply that out, is negative 2x minus 12. Then I can add 2x to both sides, get 3x equals negative 12, divide both sides by 3, get x equals negative 4, and there's an actual solution. When I take x over x plus 6 equals negative 1 and multiply both sides by x plus 6 and cancel, I get x equals negative x minus 6. Add plus x to both sides, and we get 2x equals negative 6. Divide both sides by 2, we get x equals negative 3. So that's the other final solution, the other thing that x could be for the equation to be true. Let's try another equation. X to the 6th minus 6x cubed minus 7 equals 0. And since if you took x to the 3rd squared, that would be x to the 6th, we can make a substitution, let u stand for x to the third power, and then this looks exactly like a quadratic equation where u is the variable. U being squared minus 6 times u minus 7 equals 0. Go ahead and solve that. Can you see how to factor this? It factors into u minus 7 times u plus 1 equals 0. So u minus 7 equals 0, or u plus 1 equals 0. So u equals 7, or u equals negative 1. And remember, the u stands for you better remember to unsubstitute. The u is really x cubed in disguise. So here's where we rip off the disguise and see that it's really x cubed that's equal to 7, or x cubed that's equal to negative 1. Okay, where do we go from here? If x cubed is 7, how do we go from x cubed to x? Well, we can take cube roots to undo the cubing. X would be the cube root of 7, or the cube root of negative 1. And the cube root of 7 is approximately 1.91, but if you want an exact answer, you have to just leave it as the cube root of 7. The cube root of negative 1 is exactly negative 1. So the solutions we got were the cube root of 7 and negative 1. Now, actually, there are a couple, well, 4 actually, other solutions to this equation that are a lot more obscure, complex numbers. Like when we got down to x cubed being negative 1, that means x cubed plus 1 equals 0. And if we treat that as a sum of 2 cubes, x cubed plus 1 cubed, and factor that into x plus 1 times x squared minus x plus 1 equals 0, using that factoring formula that we saw back in section P4. And now set each factor equal to 0, x plus 1 equals 0, or x squared minus, that should say minus x plus 1 equals 0. So either x equals negative 1, or the other 2 solutions to this we would have to find, maybe using the quadratic formula on this equation here, plugging in 1 for A, negative 1 for B, and 1 for C. And the quadratic formula simplifies down to 1 plus or minus the square root of negative 3 over 2. So these are also solutions to this equation. They're not real numbers because they involve the square root of a negative number. But if we wanted to be complete about it and find all solutions, not just the real ones, we'd have negative 1 and 1 plus the square root of negative 3 over 2 and 1 minus the square root of negative 3 over 2. And then we also get 3 solutions from x cubed minus 7 equal to 0. We got the cube root of 7, and then we'd have 2 other complex number solutions that we'd have to find, like using the quadratic formula on that, kind of like we did here. There's a problem similar to this on the homework, and when you do that homework problem, I'm only going to want you to find the 2 real number solutions, the easy ones. So if this were a homework problem and I gave you those instructions, all I'd really be looking for as solutions would be the cube root of negative 7 and the cube root of negative 1, which was 1. So remember back to where we got those. That would have been your solution there. I would have taken just those 2 numbers. You don't have to go any further. Okay, so I'm going to stop this video here. We've talked about equations that are in the form of a quadratic equation. I'm going to come back in the next video and look at radical equations and how to solve those.